Hello, my friends. How have you been? Are you okay? Feels tired already? It's just in the morning, come on. I'm Eric. I came all the way from Brazil. And today I'm gonna share with you some crazy experiments I was doing at home. And let me tell you, there's no such a content on ChatGPT, on Google, so you can relate that I spent a long time doing this. So it was pretty interesting, and I hope you like it. So, first of all, I would like you to get to know that all this content is already on the internet. So the last slide, I'm gonna put all the links and you can experiment at home. I know that it's 1 hour talk, right? So it's a bunch of content to absorb it, it's hard. So trying at home, I did like a special tutorial for you. And of course, take as many pictures as you can and publish on internet, mention me, mention the event, because this helps a lot with the work we've been doing. All right, very nice. I'm so happy to be here. Well, everything started when I fixed a bug in the Node.js core. So I was working, giving some classes, and I found out the child process had some problem using ECMAScript modules. I know that's a bunch of keywords, but just to give some questions. So there, because of this bug, I was nominated to become part of the Node.js core, part of the team there. And I felt so glad, but at the same time I felt like, oh my God, I'm an imposter. I don't know anything, or I'm not sure how this is working. So I was starting making a lot of questions for myself, and I was like, do I really know what Node.js is? Do I really know how it's working behind the scenes? And I noticed, no, I didn't know much. I think this is every day on our daily life, right? We are learning and we get to know that we don't know anything, or we have a bunch of new things to learn. So on my YouTube channel, I've been doing a lot of other crazy experiments like this, fixing my own questions. So I've done one, implementing the WebSocket protocol. This was really crazy, like handling binary data, and also creating a code coverage tool. So everything that I'm questioning, software programming, I'm trying to do from scratch and try teaching how was the process. So it's been really fun. Okay, recreating Node.js. The first thing let's try finding on the internet. Node.js has been there since 2009. So it must be some other crazy experiments, some ideas on the internet. Well, it turns out I haven't found anything. No one was using the same components. You could find like some old GitHub repo, but they haven't shown me the right answers. So I was like, yeah, this is gonna take me a while. Well, going to the website on Node.js, you can understand a bit of how the execution module, how asynchronous, and a lot of the beauty keyword works. But still, I needed more answers. I couldn't find like, oh, this is the Libuv that they talk. Is this executed by V8? Why there are so many JavaScript runtimes appearing right now? Is it Node.js obsolete, or why? So I started making a bunch of these questions. And then this talk, the craziest things I ever done in my life, I put also on a tutorial on YouTube. So this talk, I got some highlights for you, but I strongly recommend you going there, do the step-by-step, recreating your own Node.js, because you can find performance issues on your current applications, you can understand how Node.js is working behind the scenes, and you can fix libraries that is not following what Node.js does. Well, I just want a disclaimer here, okay? Are there any C++ developer? Oh, nice. So I think we are home, right? First of all, I'm not a C++ developer. So all the demos I'm gonna show you, you're probably gonna see some bad practices, but I try to show the easiest way so JavaScript developers can understand, okay? I know like we're gonna see very specific syntax, but don't pay too much attention on the C++. Let's pay attention what it's doing and what's the goal behind it. And also, everything here is part of my own research, okay? I was in Berlin, Ryan Dahl, the creator was there, and I was shaking because I was looking at his repo, his tweets, and a lot of stuff that he was doing in the past, and I was just making assumptions, right? I was coding, planning my ideas, but I'm not sure. He never talked to me about this, right? So it was pretty interesting. So if I say something wrong here or something that you find confusing, let's talk after the conference or after the talk. It's going to help a lot. And just a heads up, I started to give more value to those guys, to those girls who's working on JavaScript runtimes. It's crazy how they are abstracting the whole complexity so we can use JavaScript, which is a very accessible language, to create powerful applications. You're going to see in practice, sometimes no one is talking about it, and it's crazy the power we have behind the scenes to make everything work. Okay, we are here to talk about Node.js. Have everyone seen this web page before? Oh, nice. This was the first Node.js version. And you can notice there is no console.log. There is a puts, which is from Ruby, right? So the first design was just an experiment, a proof of concept that got viral and really turned into a thing. Well, I really want to understand the context behind some technology. I want to understand how was the world. So let's think a bit, how was the world for web APIs in 2009? Well, I would say, was it like prehistoric, like only bad tools there, or why? It's hard to think, right? We had a bunch of languages back then. We had Java working with JSP, servlets, P2P working with a lot of frameworks. We had C# with ASP.NET, it's where I started working with. Python with Django and Flask. You could see a bunch of technologies, right? So it's hard to think why Node.js became so popular in a world that all of those technologies were really stable, right? It's pretty interesting to see. Well, I started asking myself and asking ChatGPT about why is this so popular, and I found out back then there were a huge problem that they are trying to put more concurrent users without having to scale more servers. So all of these languages, they have a similar execution module. I'm going to tell a bit more in a few slides. But it's pretty interesting. Everyone was following the same idea, and in Node.js, everything has changed. I don't know about you, but when I started programming, for me, it was completely overwhelming. I had to learn C# for the server. I had to learn ASP.NET for the server to create web APIs. SQL to handle databases. I had to learn JavaScript to make some integration. CSS, HTML. My God, it was crazy. I thought I would never be a good programmer. I would never learn this thing. So with JavaScript, we have one language that can work in both back and front-end side, and this was a game changer for everyone. So now you can make people work faster, but it's not just it. Node.js has a very clever execution model. The way it has changed everything. So let's think about how was the execution model, the popular execution model back then. There we had like data centers, okay? And we had requests. So when a request goes to the website, usually those languages are putting threads with some resource groups there for each individual client, okay? Each individual request, they have a small piece of memory, CPU, and processing power. Well, if you wanted to put more and more concurrent users, you're going to be limited on what your application or what your servers has on the resources. So what happened? You are putting a lot of customers at the same time. You don't have memory. You have to scale up faster, and then you're going to see a lot of problems. This is mainly caused because the blocking I/O, which is two tasks there that are trying to access a file, access a databases, they are basically pausing so other processes can finish first in a big picture. And threads are heavy in those scenarios. So imagine for each customer, I have a bunch of threads, a bunch of resources, so it's pretty expensive for the web services, which it was hard to handle concurrent users, and usually we had like huge servers to handle all of this. And it's not that it. When you work with threads, threads has to be carefully managed, so you can avoid the deadlocks, right? So this is when two applications or two processes are trying to change the same value in memory, the same reference in memory. Usually the server just breaks and say, oh, I don't know who you go first, so we have to implement like semaphores and a lot of crazy concepts. With Node.js, none of this were a problem. Node.js came with another complete different approach, so you can handle multiple and concurrent users. You can use real-time applications by changing the whole way. So in Node.js, the execution model is a bit different. It handles a bunch of users by using a very interesting execution module. So everything inside Node.js is asynchronous, which means that my application can schedule tasks, can schedule background programs, and then when these programs are ready to respond, they call them back and the application is running. So we have a loop there. Instead of having a lot of resources and threads for each individual user, Node.js just pre-allocated on the startup. So we have everything on the startup, and then we can start reusing for each concurrent user. So now we can have all those users. When I'm receiving those requests, I'm putting on a queue there. I'm scheduling those requests, and then I can receive a bunch of users. I can just in-queue them on my processing time. But then we have something that is very known called there as a loop, right? As event loop. So when this loop is running, it's removing or responding to the users without having to pause the process, okay? So on the main thread, we have all this dispatching of events, and then in background, everything is running seamlessly by the process. So the main thing for Node.js, it's not reserving memory for each individual client. It can reuse more memory, so that's why there are a bunch of people using like Raspberry Pis, like small servers to handle a bunch of concurrent users using Node.js. Okay, so just to highlight, Node.js was amazing back then because it uses a non-blocking I/O. So this means that it doesn't need to stop the main thread. It doesn't need to block an execution for some task. And it uses the lightweight processes. The event loop in the end is like a while-true event, a while-true loop there that's just asking for more events, dispatching, and just making the link between your operating system and the user interface, right? The request itself. And then it enforces asynchronous programming. So now you can schedule tasks in background. You can use more the power of your machine to get all this. So you can handle multiple tasks in parallel and running a bunch of other things in asynchronously, right? And the whole goal was to create real-time applications. So now concurrent users are not the problem anymore. And just, I think, just a last myth before getting to the code, right? Node.js has always been working with threads. But I've seen people say, no, JavaScript doesn't have threads. Node.js doesn't have threads. And this was really weird for me, really misleading. So I wanted to see in practice how this works. Node.js do have the thread since the beginning. So when I was looking at the V001 form, I was like, oh my God, there are threads here. So everyone else was telling me wrong, right? This is why I think only believing in theory doesn't make sense. We should try and understand how this works behind the scenes. When you go to the Node.js website, you're going to notice the worker pool. The worker pool are usually 4 threads that Node.js puts on the startup, right? So it's scheduling a worker pool so you can run intensive CPU tasks behind the scenes. So there are a bunch of tasks here. Don't worry, let's just highlight what is important. So Node.js uses threads 2 expensive tasks. And those tasks would be I/O intensive, like DNS, that is synchronous. So Node.js has to have some way to execute them in parallel. Or CPU intensive, crypto, encryption, compression of files, and much more, okay? However, since the V10, we have the worker threads, okay? And then people were like, oh, well, Node.js has always used threads, but it wasn't available, right? It wasn't on a public API. Now you can use this API to create and process more things, more CPU-intensive tasks behind the scenes, okay? But usually this is for very specific, very edge cases to use on your JavaScript applications. Well, and we were talking Node.js is multi-threading, but the event loop is single-threaded. And this is what makes this special. The event loop is single-threaded, so it doesn't need to check variables, okay? Every process is executed sequentially and just receive the data back and forth from the operating system. So this is really fast to execute, and this is very crazy. I'm going to tell about all the keywords, but just so you know, the Libuv that we are talking a lot for the event loop, the Libuv was made for Node.js to work on Windows, on Mac, and a lot of operating systems. All right, a bunch of theory, right? I think it's time to get in some code and see how this works in practice, right? So for me, now it's time to see the magic happening, right? So let's recreate Node.js. What I meant while I speak recreate Node.js, I want to use the same components that Node.js is using, and I want to do at least a set timeout, because I want to use the V8 that I didn't tell you yet what is this, and I want to use the Libuv to create process in background and see everything working. This was the goal I was trying to find. So I found the internet. I could find some examples on running only individual pieces of those projects, but none alone. And then I always go to the repo, the Node.js, and I try to understand how Wendel, how the creator, was thinking when he was the first version, right? The 001. And I would say it's pretty interesting. Sometimes we have our heroes, and we are like, oh my God, there must be the best programmers in the world. They don't commit fails. But you're going to see on the commit history, it's really interesting. First compile, intermediate commit, nothing working. He just put 3 dots there. I have no idea what he meant. And then add a web page, very incomplete. So you can see he's very perfectionist for everything, right? Trying to implement stream upload, not working. This is interesting for me because when it's not working, I don't usually put on the repo, right? But he said it was a proof of concept. He wasn't aware if everything's gonna work, so he was just trying until it worked. Well, and you see this code, the V1, all right? The first release was just in 2014. The 001 was 2009. So you can see a huge gap there, right? Node.js back then, they have a very, the community and Giant, the company that was behind the Node.js, they had a fight. So Node.js had a fork on this, and they start calling this web IOJS, right? So it was pretty interesting because we had 2 exactly the same projects running and a lot of fight on the community. But hopefully all this fight has passed and Node.js is working fine with all the community. Okay. All this project, I told you, using all the components that Node.js is using, is already on the GitHub. So you can find all the code, and I call this capybara. So capybara is a very known animal in Brazil, so I try to bring some references. And I'm going to tell you, I spent at least a month doing this project. So first I tried to compile and to execute different libraries, right? Different process. So the first one was the V8. V8 is the JavaScript interpreter. So it's like I'm using eval in JavaScript. I can send a string to this library or to this component, and it's going to evaluate my code and return the result. Okay? Just it. Well, but let me tell you a story. When I got there, I tried to follow the step-by-step following the docs. It wasn't working well. I just changed my Mac from an ARM to an M1. It was, my God, it was crazy, crazy. So just you know, the first process is downloading from the repo. So after I download this from the repo, it's gigabytes. It's crazy, massive files everywhere. I had to set up the architecture. So now I'm using M1, so I had to recompile everything for my machine to work. My God, C++ is pretty hard. I'm not a C++ developer, but I suffered a lot doing this. And I had to start compiling. So this is the time you go there, you get your coffee, you talk to your wife, because it's long time, right? And I would say on this process, going back and forth, I spent 3 weeks because I was compiling the code, I wasn't getting the right results, it always missing some files, and it was pretty hard. But after you do the right way, you wait at least 1+ hours so you can see everything working. After you compile the code, it's going to be like 8 gigabytes there, the final project, and you can run the tests. So you can run all the V8 tests that is testing how the language works itself, and you can copy the binary and the headers. Well, this time you're going to be thinking, oh my God, it's too much information, right? When you go to your home and you try to do the tutorial, I did everything more straightforward for you, okay? So I set up a cloud environment on the Git pod, and there I compile those libraries, I put in there so you can only think about the code. So when you go there, you're gonna see all the dependencies are already there, so you can only focus on C++, Node.js, Libuv, and so on. If you want to try, I put the link and the scripts there, but it wasn't a really easy task to start working on. Okay, we are here to talk about JavaScript, Node.js, and all those fancy logos, right? So I'm going to show you now the relationship between them. So if you forget everything from this talk, I want you to remember just the next steps, okay? So V8 is our interpreter. Libuv is the event manager, right? Everything that goes asynchronous, we use Libuv. And C++ is what we call the bridge. It's the link sending data from one side and calling other side. So how this works in practice? V8, as I told you, is grammar, right? All data types, all data structures that are in the JavaScript side on the ECMAScript is there. So const, function, classes, promises, map sets, and so on, okay? You're gonna notice here that there are no console.log, there are no there are no set timeout, set interval, immediate. It's weird, right? So when you get the V8, it's very raw, so you can start implementing your own functions. So we have the Libuv, and in this case, the Libuv, I'm gonna tell you, it's just a while true asking for events, okay? It's going to go there and say, oh, is there any asynchronous event pending? I'm gonna dispatch them all, and I'm gonna use there. And then we have where the magic happens, where I think that those JS runtimes authors, they help us a lot, because it's here how they make JavaScript powerful to work on servers, and even on browsers, right? So imagine I have a JavaScript file, okay? We have the context, the global this of JavaScript, and there's nothing there, right? It's completely empty, so we had to start implementing functions. I won't implement console.log. I'm going to implement print, okay? So this print function, it doesn't exist in JavaScript. So if I try running this function, it's going to show me that's undefined. So what I do, I go to the C++ side, I implement a new function there, okay? And with this function, I'm going to extend V8 and say, whatever you have this call, you call this C++ function. Okay? So this is how all the magic happens behind the scenes. This is how FS works, HTTP requests, and everything that you can use from native modules in Node.js. Oh, bless you. Nice. What if I want to implement set timeout? Set timeout is a bit harder, right? I have the set timeout. I will make exactly the same thing for the C++ side, but notice that now I'm using UV timer start, which is like everything that goes outside my code, everything that relies on the environment, I'm gonna call from libuv side. And now on V8, you can see all those functions, right? All those functions are now mapped there as if it was JavaScript, as it was always there. So this is the magic behind most of the runtimes right now. Well, I would tell you that my first thing was, oh my God, this is just extending V8, right? So in the end, I'm just adding new functions, but how Bun or how Deno or other runtimes are so popular now if they are just doing the same stuff, they're doing the same idea? Well, we're gonna get into it, okay? Now I'm gonna show you more code. Now I'm gonna show you how the process is working behind and what is cool about implementing this code. All right, first of all, I have my code here, okay? So it's a JavaScript code. You can see just a print and a new date. The date object is interesting for me because date depends or relies on your environment, right? But it's the only thing on JavaScript that can follow this idea. Otherwise, other runtimes or other platforms, browsers could implement themselves. So here I have all the structure for my code, okay? But let's take a look at some ideas here. I have very C++ code, and the C++ code is just getting the arguments and getting a file name, and it's gonna read this file, and we start executing it. So I'm gonna go there and see. Let's see step by step, right? I receive the file name, okay? And in the file name, I'm just reading a file, just it. I'm gonna get all the JavaScript code, and I'm gonna put on a variable, okay? Then I'm gonna use this compile. This is why I was telling you, JavaScript doesn't exist. JavaScript, in the end, is just V8 translating all those strings or all that grammar to C++ instances. For me, it was like, oh, this is pretty mind-blowing. And then, just to check it out, what is inside this read file. Actually, we have the script run. So the script run is the eval, right? Is the execution. So before I compile it, I have the C++ extensions and C++ functions, and then I probably execute it. But let's take a look here. I have the wait for events. I'm gonna show it later. But just so you know, see, oops. Let's forward a bit. Just so you know, the FS file that I was telling you, the read file is just a C++ function. Let me get here. So I'm using the most primitive way of reading files in C++. This is very C++ side, but for me was, in the end, it doesn't matter what is the platform. It just matters what is the APIs you're calling to interact with your operating system. It could have been Rust. It could have been any other programming language that is interacting with C++. And here, you can see that I'm not using libuv, right? I'm using the C++ native abstraction here. But I'm using this because on the startup, I just want to get all the content from the file and execute it. I don't need to be asynchronous this time because the startup is the most important thing right now. Nice. Okay, so now I have to get all those binaries, right? I have to put on the same directory, and then I have to make a way to link all them together. So when I'm using C++, I have to tell where is the binary, okay? The binary is that monolith.a, that usually is like 100 megabytes, just this binary. And then I have to put all the C++ includes, which is the references on how I'm going to call functions from that binary. And then I have to put all my directory, and the same for Libuv. So environment is really, really painful. This is why I think having this on Gitpod is going to help you a lot to go forward. OK. I'm not a C++ developer, right? I'm a JavaScript developer, and I use NodeMon a lot. So I was like, why not using NodeMon to evaluate my C++ classes? So I'm using a NodeMon here to execute the make file and then run the binary. I don't know much about C++ or their tooling, so I try using what I already knew. So it was really, really interesting. And here, if I try running, I run the make file, OK? And then it's going to generate a binary for me. And with this binary, I can execute it as Node.js is executing, right? Node.js is just a binary. It's just a C++ file that's receiving a string, a file, and evaluating this data. For me, it was really unmystifying, right? OK. I was telling you that console.log doesn't exist, right? So what happens if you try calling console.log? Let's check this out. This was really, really interesting for me. If I go there, I print console.log and see, nothing happens. Not even an error, right? I should see like log is undefined function, right? But no, I haven't seen any output here. However, if I use my print function and put the console log there, I see the console, I see it's an object. I was like, wait. Console.log is there, but it's just not working, right? If I get the keys from this object, I'm going to see all the functions there. I was like, why do you have all the functions, but I cannot execute them? So this is just a standard. I would say V8 is doing this just to make you make your program happen better. One thing that I keep telling you, but for me was the mind-blowing stuff, is set timeout, set interval, and console are not JavaScript. This means that if you execute your JavaScript code on the browser is responsible to implement the console log or the set timeout implementation. This is why Firefox, Google, and all those browsers are fighting now, because one can be faster than another, implementing their own way to execute those functions. So this is pretty nice. If we go back to our code, what happens if we go there and type the set timeout? Not defined, right? Very different than the console example. OK, what about the interval? Same problem, right? Not defined. Well, actually, it's not just messy, OK? There are working groups that tell us how console and how timers should be implemented in JavaScript runtimes. It's not just messy, OK? But they are not there by default, and it's pretty interesting for me. OK, we did the print. The print was just a printf on the C++ side, nothing fun. But now I want to link all of the libraries, all the dependencies, so you can try at home and try even implementing Node.js if you want. But see, here I have the print function. And the first time I saw this code, I was like, oh no, man. Printf. When I was in the university, the printf was like the first function I saw in my life, and it's been using since like nowadays on the Node.js side, and it's pretty interesting. It's a bunch of information, isn't it? So here, I have the C++. I'm going to try doing the same thing I showed you on the diagram. So I have the C++ function, the print function that's going to be called from JavaScript. I have to extend this C++ side, right? I have to extend the V8 object and say, whenever someone calls print, show this function. And after it, we can execute. And just so you know, the print function is here just to print out the information. But I'm going to show you that JavaScript is much more V8. There are a lot of things there, right? Just doing only the print function. I didn't do any other object. But you see, new date is there. Two isostring is there also. String templates are there as well. And even complex instruction, complex objects, such as map and spread operator. And surprisingly, promises are not async functions. Promises are just abstractions, so you can use callbacks behind the scenes. This was like, oh my god. So yeah, promises, they are not making anything async for you, just helping you out to work with your functions. Nice. We have implemented the print. Now let's implement the set timeout and set interval, right? So yeah, it's time. For me, it was one of the most interesting things to do because when I have to execute, remember, Node.js can handle multiple concurrent users, right? A lot of users executing the application. But when I have the set timeout, I have to schedule a function that's going to be executed in the future. So that piece of object, those parameters should be in memory when I have to access there. So I was like, oh my god, how Node.js is doing this for so many users concurrently? Well, let's go there and let's find out. So I have my timeout function. Again, it's C++, but just let's get the concept. I'm getting both parameters here, they sleep, how long the timeout's gonna happen, and the interval. So if it's an interval, it's the same function, I just change the parameter there. Another thing, I'm gonna call and see if the user passed a callback, so I can call it in the future. And now it's this part here, I spent, I would say, 2 weeks. I almost gave up doing that because I didn't know how to store those variables, how to store those objects. So I started making calls to people from Google, and they were like, I have no idea what you're doing, but some guys has helped me to really finish it. So this is a struct. I'm using some Node.js, some V8 instructions there, but I'm just storing those objects, storing those parameters to be executed in the future. And now I use the Libuv methods. When I saw people on the posts, on articles, I thought it was way harder, right? But it's just C++ instructions. It's just functions as we do in JavaScript. So when this function executes, I have the callback there. So the callback will say, well, now it's time to execute it. Execute the callback that the user just passed to you. And this is so magic that we can invoke the JavaScript code. See, JavaScript doesn't exist. We are invoking the V8 call, right? The V8 function, which is an instance. This is why I'm telling you that JavaScript is just, it's like an intermediate language for us, right? And then, see, if we go to the JavaScript side now, actually, we have to put all the event loop, right? The while through there to wait for new events. So the set timeout, reach the time, the Libuv is going to schedule and release all the process for this function. And then we just call it right after compiling and executing our code. Okay? Nice. Don't forget to put on our context as we've done to the print, and now it's going to be available on the JavaScript side. And see now, look how amazing is it. On the JavaScript side now, I have the timeout, right? So I have all the abstraction. And remember, my timeout, I just, to make the interval, I just have to switch the parameters and the receive callbacks. But, as I was telling you, promises, they are just abstractions, right? Promises are just a way to help us to wait for results. However, when I'm doing this, I can use async and await. And if I run this code, it magically happens, magically works, and wait for the seconds and wait for everything working. I wouldn't say, I cannot explain how it was for me to reach this result. I was like calling everyone, like, oh my god, it finally worked. Because it was pretty hard. And Node.js is, C++ is a new word for me, so I was struggling a lot. Well, Node.js, in the first version, when I was looking, I saw that Erick Wendel did a very similar code, right? You can see he was using timer, and he was exposing those functions from there. So when you go to the Node.js source, we're going to see a bunch of C++ code and a bunch of JavaScript code, right? So what they are trying to do, they are trying to expose those APIs so you can make your own abstractions from the JavaScript side. So you don't need to handle concurrency or handle those weird syntax from C++. So remember, JavaScript, it's only about ECMAScript specs, okay? So if you're not working, if you can see that those functions are not working, it's probably not in the JavaScript, in the ECMAScript specs. So you can have implemented by yourself, okay? Well, the next chapter now is trying understanding why we have so many JavaScript runtimes now. I saw Bun, and Bun is very interesting, but Deno I like more because the fight, right? Deno is just the Node.js backwards. And I think my whole motivation was, is it that easy to create a JavaScript runtime? Are they making money? Why they are creating a lot of JS runtimes? And how is this good or bad for our community, right? Let's talk about Deno. Deno has a very good approach using TypeScript, instead of using Libuv, it's using Tokyo, which is in Rust. So the whole project is Rust. And the architecture is very similar. If you take a look at the code, you're going to see there that they have a execute script, which is the function that translates the JavaScript code now to Rust, right? Exactly the same thing we were doing in the C++ side. If we look at the execution, exactly the same way. They are compiling and they are executing and get those magics using the V8 APIs. So it's just a different programming language, but doing exactly the same workflow. Well, and if you go there, you can see that Deno is injecting a lot of functions on the global stage, right? On the global this, as I was doing on the diagram, remember? So exactly the same idea behind the scenes. What about Deno? Oh, what about Bun? What about Bun? Bun has using Zig. I don't know. For me, it was crazy. Zig, there are just few content on the internet, and they are using JavaScript core for the JavaScript runtime. JavaScript core, there are almost non-documentation. So probably this guy has some information that we don't know because the docs are almost null, so I can't find anything. However, when going to this website, you're going to see a bunch of imports. So we can see JavaScript core there. You can see a bunch. In this case, is C++, right? So he's trying to do some bindings to use on Zig. But it's exactly the same idea. I wouldn't go further on this code because Zig is very confusing for me. So I didn't go much, but it's exactly the same idea. Extending one function or extending ideas from the existing JS in runtimes. Now we start making questions, right? Well, they are all extending JavaScript runtimes. What makes one faster or better than another, right? So why are they fighting now, or why they are competing in this market if they are trying to do the same exact thing? Well, let's see this code. This code is for the FS, the Node.js library to accessing files and all the file system APIs. Node.js has a bunch of APIs. Deno, the same thing, and Bun, the same thing. But what makes one better than others, it's how they handle these responses from the operating system. So the operating system, you are calling for a file. The file would be big, right? But you are handling it on demand. You are responding to the JavaScript side on demand. So this is how one could be faster than another. So let's say that Zig, for doing loops or handling buffers, which is a crazy idea behind the scenes, is using a better approach. But I would say nothing of this is important for us if we don't have a good developer experience, right? So developer experience for me, it's where Deno was pretty good, right? It just started with testing, and it just started very performatic. It was starting with TypeScript, so a lot of people loved it. But for me, it's crazy to see how Node.js has improved because of them. Node.js has now a working group for performance. They are, if you go like from the version 16 to 20, you're gonna see a complete different platform. So it's getting faster every day. And remember I said to you, right, about the competition. Let's see this. Jared Summer, which is the Bun's creator, he's joined Node.js. So he's there trying to collaborate, try to understand, getting ideas from Bun and back and forth. Colin Rigg was one of the maintainers, or I think he's actually is maintainer of Libuv. It was one of the first developers of Node.js. He has worked at Deno, and they are all contributing together. And you see, the test runner was a big thing in the Deno side, and we brought to the Node.js, and I personally, I've been working a lot on this. A lot of information, isn't it? Oh, I see just like 404 faces from here, but it's been nice, it's been nice. I think you're gonna have time to digest later. Well, something nice about those collaborations, right, are the working groups that have been appearing. I think in the future, we won't have to change or we won't have to choose whether it's Node.js, Bun, Cloudflare workers, or whatever runtime. We can say, oh, AWS, I want to run my JavaScript side here. The APIs are the same, so the platform could choose it. So this working group is meant for them to collaborate and to talk to each other about the same. All right, so as I told you, this tutorial will help you a lot. I think you're gonna observe more when you are typing. I know it's hard sometimes to listen to this kind of stuff, but I enjoy it so much because now I can understand better and I can actually troubleshoot my applications better. I can say, probably I have a memory leak because the event is taking too long. Or probably I have this JavaScript code, which is a while loop handling a million items in memory. Probably it's there because it's not asynchronous. So when you start paying attention on how the behind the scenes work, this helps us a lot to improve our current applications. Nice. So all the content I'm talking to you is already on my website. All the talks I've been doing, all the JavaScript crazy ideas I've been doing is already there. And for this specific talk, I did an ebook. So on this ebook, you can go there and you can do the step-by-step from the book, but it's not just the step-by-step as the video was showing you. You can go there and implement your own FS module. So it's pretty interesting. All right, so we have a few more minutes right now. I'm gonna open for questions. I know that's a very crazy subject, but if you have questions, you can raise your hand. So we can do. Any questions? It's crazy, isn't it? Like our mind is freezing out right now. Okay, so before I finish this talk, right? We have a tradition. So I'm gonna put the last slide here so you can take a picture and get all those references, all these links, all the slides also. But before we finish, we usually do a crazy stuff, right? Just to make people at home envy. Let's make a selfie. Let's stretch a bit out, right? And get ready for the next talk. So, I'm gonna count 3, and we're gonna do whoa, okay? I'm counting on you, eh? 1, 2, 3. Very nice. Thank you so much for having me.